Hello, everyone, and welcome. This presentation is titled The Use of Generative Artificial Intelligence in the Planning of Teaching Practices in Inclusive Special Education. It brings together 6 authors. Denise Flora, Simone Mafficcioli, and Walkiria Mendonça are teaching initiation scholars in the PIBID program at the Federal University of Santa Maria. Student teachers in special education, in other words, near-future professionals. They work together with Sabrina Castro, also from UFSM, Yasmin Zanchi-Bouari from the Federal University of Paraná, and Victor Gonçalves from the Polytechnic Institute of Bragança in Portugal. This study grew directly out of Denise, Simone, and Walkiria's PIBID fieldwork in schools. Let's begin with the context. Brazilian law guarantees inclusive education for students with intellectual disabilities and autism. To support this, schools provide specialized educational services. In Brazil, we call this AEE. It is important to say that the AEE does not replace the regular classroom. It complements it and removes barriers to learning. But this creates a real challenge. Teachers are under great pressure to adapt complex content on the spot without overwhelming the student and without separating them from the rest of the class. This is where our project comes in. The EduESP Pocket Guide is a prototype developed under the PIBID program by these near-future special education professionals. It is the result of a partnership between 3 institutions: the Federal University of Santa Maria, the Federal University of Paraná, and the Polytechnic Institute of Bragança in Portugal. Its mission is to be an AI-based assistant that helps teachers make decisions, and its goal is to personalize instruction for students with intellectual disability and autism, making teaching inclusive, accessible, and efficient. Our work stands on 3 pillars that build accessible learning environments. First, the Individualized Education Plan, the IEP, the mandatory document that maps each student's barriers and the strategies to address them. Second, the National Common Core Curriculum, the BNCC, which makes sure that special education students learn the same core content as their peers. And third, Universal Design for Learning, or UDL, which calls for multiple ways to present content and for students to engage and to show what they know. A key idea in our study is that prompt engineering is a new teaching skill. Why? Generative AI works by probability. It predicts likely sequences of words. Without clear limits, it can produce inaccurate, biased, or inappropriate content. So a good prompt works as a filter. It must define the student's exact abilities, interests, and age. And here is the most important constraint. We must stop the AI's default tendency to create childish materials for people with intellectual disabilities. Treating a 14-year-old like a small child causes deep demotivation. To make this concrete, our case study centers on one student. To protect his identity, we call him Raphael. He is 14 years old, in year 8, diagnosed with an intellectual disability. His profile is mixed. In communication, he is emerging. He speaks softly, is shy, and relies on gestures. In reading and writing, he is at a foundational level, recognizing letters and numbers up to 20. His socialization depends on the context. He keeps to himself at break, but works well in small groups. And his independence is high. He manages his own meals, hygiene, and clothing. Our method followed a 6-step loop. 1. Observe Raphael, in the resource room and in the regular class. 2. Assess his support needs, using the SIS-A scale. 3. Select the right AI tool for each subject. 4. Draft prompts tailored to his persona. 5. Implement structured routines with concrete materials in small groups. And 6. Reassess, using descriptive reports, portfolios, and interdisciplinary meetings. Here are the results, organized around Raphael's curriculum. For each subject, we set an objective, an adaptation, and the AI tools. In Portuguese, the goal was text comprehension, using pictograms and read aloud. In mathematics, decimal numbers and quantities, with visual aids and bottle caps. In science, the states of water, using real images and custom music. In history, indigenous culture, through illustrated comic strips. And in physical education, motor skills, with visual and verbal activities. Different tools fit different needs: ChatGPT, Gemini, DALL-E, Suno, and others. This slide shows how a prompt becomes an accessible product. On the left is the input. We ask the AI to rewrite a text on waste sorting, using emojis as pictograms, with short sentences, accessible to a 14-year-old with an intellectual disability. On the right are the outputs: a simplified, illustrated text on organic and recyclable waste, for Portuguese. And for science, a short song about the water cycle, created with Suno. In the discussion, we weigh capabilities against ethics. On the value side, AI brings gamification, turning plain text into quizzes, word searches, and comics. It supports UDL by quickly generating content in many formats, and it saves time, freeing teachers for direct teaching. But each gain has a matching requirement. Age appropriateness needs constant refinement to avoid childish materials. Bias must be checked because outputs can be plausible but wrong. And human mediation is essential. The AI is an assistant to the teacher's authorship, guided by the Brazilian Artificial Intelligence Plan, the BAIP. To close, we see technology as an ally for educational equity. AI optimizes planning time, speeding up the creation of individualized education plans so teachers can focus on meaningful, in-person interaction. It enhances accessibility, reducing barriers and supporting autonomy and self-esteem without separating students from their peers. And it empowers future educators, training undergraduate teachers to use AI critically so the next generation can build truly inclusive, technology-supported classrooms. These are some of the foundational references that guided our work, including Aruda on generative AI and teaching, the Brazilian AI Plan, the UNESCO Guidance on Generative AI in Education, the CAST Guidelines on Universal Design for Learning, and Camargo on avoiding the infantilization of people with intellectual disabilities. Thank you very much for your attention. This study was carried out by Denise Flora, Simone Mafficioli, and Walkiria Mendoza, our PIBID Teaching Initiation Scholars, together with Sabrina Castro, Yasmin Zainchi-Botri, and Vitor Gonçalves, across the Federal University of Santa Maria, the Federal University of Paraná, and the Polytechnic Institute of Braganza. We would be glad to answer your questions.